Now, this leads us to discuss the trans fatty acids. Trans fatty acids became a problem because many decades ago, we decided that we wanted to take our vegetable oils and make them more solid-like. And we figured, well, if we make them more like lard and we replace lard, a saturated fat, with basically these, synthetically produced fats, that originally came from vegetable oils, it should be good for us, right? Well, what we didn't count on was the part of the process in making the what we call partially hydrogenated oils. Basically, what happened was in the process of making them, we used a relatively low. And basically, it was done with hydrogen and a catalyst. The idea being that we're going to take the carbon-carbon double bond that we see here and essentially put hydrogen across that double bond and make a saturated fat. The problem is that the process used relatively low pressures of hydrogen, the idea being we wanted to achieve partially hydrogenated, not fully hydrogenated fats. So, as a result, because of the low amount of hydrogen in the mix, a lot of times this double bond would react with the catalyst, but it wouldn't have the hydrogen needed to actually get hydrogenated. So it would dissociate from the catalyst, and when it did so, basically binding to the catalyst results in a reaction where the electrons in this bond actually form a bond with the catalyst. So when there's no reaction, no hydrogen available for reaction, and this double bond reform, it does not reform as the cis double bond, it actually reforms as this trans double bond. The thing to notice here is that oleic acid doesn't sit very nicely against stearic acid, whereas ellatic acid, which is pretty much identical to oleic acid with the exception that the double bond present is a trans double bond, ellatic acid actually sits very nicely against stearic acid and butts up pretty nicely, forms a nice crystalline structure. So trans fatty acids tend to have a lot of the same properties as saturated fatty acids. However, there is one distinct difference in that the way they are metabolized, a saturated fatty acid versus a trans fatty acid, are metabolized at much different rates. As a result, there are some very big changes that occur as a result of having trans fatty acids around. One of them is simply a general increase in lipid levels in the blood. Now, whether this is a pure causation event is hard to say, because generally people who ingest a lot of trans fatty acids generally have a pretty poor diet. We find trans fatty acids in really, that 2-pound bag of cookies that cost, $1.50 at the grocery market. That's what we're talking about in terms of containing large amounts of trans fatty acids. So in general, the people who are eating that are not eating the best diet, and thus they're going to tend to have a variety of other problems in addition to the trans fatty acid problem. So what we see in these people, a lot of the conditions that are leading to diabetes. So we see very high lipid levels, high levels of low density lipoprotein versus high density lipoprotein. Basically, your ratio of LDL to HDL is relatively important in determining overall cholesterol health. And we'll talk more about this in several chapters. We also see a pretty drastic increase in the levels of the triglycerides, and this is basically moving lipids around the body as a result of increased ingestion of a wide variety of fatty acids. So in general, avoiding trans fatty acids is a pretty good thing to help with an increased level of healthiness. So about a little over a decade ago, a little bit more than that, we started requiring that foods be labeled as having trans fatty acids. Well, unfortunately, the food processors were not too keen to do that. They didn't want to slap a label saying that their product contained trans fatty acids, any sort of trans fat. So they started coming up with very creative ways of getting around those words partially hydrogenated, because that became the key to look for, was partially hydrogenated whatever oil, like partially hydrogenated soybean oil or partially hydrogenated cottonseed oil. And instead, they started to use a term called interesterified. And what interesterified means is that the fat in question has been treated, usually by the partial hydrogenation process, and then the fatty acids have been released from the triacylglycerol and then reformed back into a triacylglycerol. And all you have to do is report the last thing you did to it. So the last thing that was done was interesterification. That was done after the partial hydrogenation. So as a result, we can put on the label that we did partially hydrogenated. Instead of saying partially hydrogenated, we simply say we interesterified the fat. And that's why you see interesterified fats instead of partially hydrogenated fats largely on labels nowadays. It basically just is kind of one little loophole that our food manufacturers are utilizing to get away reporting what is actually in the food that they're serving us. Additionally, we can, although trans fat is supposed to be reported in terms of the number of grams, one of the things that we see is that as long as you don't have more than half a gram of trans fats in your serving, well, you can basically say that you have 0 grams of trans fat. And we got to keep in mind what a serving is nowadays. A serving has actually decreased in size, whereas a few years ago, a serving might have been 2 cookies. Now, very commonly, 1 cookie is considered a serving. So, and as a result, if you have 0.45 grams of a trans fat in 1 cookie, and you have taken your serving size from 2 cookies down to 1, 0.45 grams, you don't have to report it. But if you basically eat a more typical serving for somebody in this country, you might find yourself eating 2 or 4 or even more cookies, and therefore you're getting your full-on daily dose of the trans fats in your diet. So the next question, what is an omega-6 versus an omega-3 fatty acid? Basically, let's look at an example of each. Up on top here, we've got linoleic acid, an omega-6 fatty acid. And the way that we classify this as an omega-6 fatty acid is we look at how far it is from the last carbon to the lowest priority double bond. So basically, we've got 1, 2, 3, 4, 5, 6 carbons. Whereas an omega-3, 1, 2, 3. So basically, the omega basically meaning end in this case, how far is the double bond from the end of the fatty acid? So the difference between omega-6 and omega-3 fatty acids is largely in what we do with them. Generally, omega-6 fatty acids, we tend to make some molecules that are not terribly healthy for us when produced in high levels, whereas omega-3 fatty acids generally tend to be protective of us. So as a result, this is why we want to make sure that we have plenty of omega-3 fatty acids in our diet and also limit the amount of omega-6 fatty acids that we have in our diet. So a few important dietary omega-3 fatty acids include the molecules EPA for eicosapentaenoic acid and DHA for docosahexaenoic acid. Basically, these are going to be derived largely from plant sources. In fact, algae is a great source of EPA and DHA, and fish tend to eat algae, and then fish tend to eat other fish. And eventually you get a top predator fish like salmon ingesting fish that have ultimately consumed a fairly large amount of EPA and DHA. And that's why salmon are a great source of these omega-3 fatty acids, simply because they are eating fish that have eaten other fish that have ultimately eaten algae. So anyways, the EPA and the DHA tend to get concentrated in organisms like salmon, and that's why it's suggested that if we want to get our proper dose of omega-3 fatty acids, eating salmon is a great idea. Now, you'll notice that these are relatively long molecules, 20 and 22 carbon. In general, we have often hear that flaxseed is high in omega-3. And yes, this is true. But flaxseed is largely high in the omega-3 fatty acid alpha-linolenic acid. And alpha-linolenic acid is not that useful to us. We need these two fatty acids. We cannot convert alpha-linolenic acid into these two fatty acids here. So as a result, we have to get these from our diet. And thus, when you see the notice on the flaxseed meal that this is a great source of omega-3 fatty acids, they're not lying to you. It is a good source of omega-3 fatty acids. It's just not helpful omega-3 fatty acids. So this is one where, a little bit of knowledge is kind of a good thing, because you know that, they're not lying to you technically. They're just not telling you the full truth.